Hi, my name is Michael, and today I'd like to talk to you about two of the rules which I think are most important when you're doing mathematics. These are what I call the rule of expressions and the rule of equations. Let's do the rule of expressions first. In mathematics, an expression is a combination of variables, numbers, perhaps functions, that doesn't have a comparator like an equal sign in it. So for example, here's a simple expression. X plus 2 over 3. The rule of expressions is quite simple. It says I can do anything I want to this, absolutely anything, as long as I don't change the value. So for example, if I wanted, I could replace the 2 with 1 plus 1, because of course we know that 1 plus 1 is 2. Now you might have this question, how do I know when I'm doing something to an expression? How do I know if I've changed the value or not? The answer is it's actually relatively simple to test. All you do is just pick a number, plug it in for x, and see whether or not the total value has stayed the same. For example, I could plug in 4 for x here, and we'd have 4 plus 2 is 6 over 3, which is 2. Down here we'd have, plugging in 4 plus 1 is 5, plus 1 is 6, over 3, and that's still 2, so what we've done is just fine. So then what would be an example of something that I could do to this expression, that might look as though I'm not changing its value, but actually I am? Well, one thing I could do is I could take this expression and I could, say, try squaring both the top and the bottom. Now, I'm doing the same thing to the top and to the bottom, so it might seem like I haven't changed it. But let's in fact see what happens if I square the top and the bottom. So I'll do that down here. Okay? Now once again we're going to try plugging in 4. 4 plus 2 is 6, over 3 is still 2. Over here when I do 4 plus 2, that's 6. 6 squared over 3 squared, which is 36 over 9, which is 4. And of course you can see the two expressions no longer have the same value. So this is an example of something that I cannot do. The other rule, which I think is of absolutely fundamental importance if you're going to do math, is what I call the rule of equations. And the rule of equations is similar to the rule of expressions, but it's actually a bit of a relaxation. In the rule of expressions, you'll remember, you could not do anything to an expression that would change its value. Now, if you have an equation that is something that contains an equal sign, you can change its value if you want. In fact, you can do anything you want as long as you change the value on each side of the equal sign in the same way. An analogy that's often used by teachers is to think of an equation as a balance. You can remove something from one side of the balance as long as you remove an equal amount from the other side so that the balance stays balanced. So, for example, here we have a simple equation. If I wanted to solve this equation, I would have to change the values on both sides because I'd have to get all the x's on one side and get all the numbers on the other side. Well, I can do this in the following way. I can subtract x from both sides so that I have 2 equal to 2x minus 6. I can add 6 to both sides so that now I have 8 equaling 2x. Then I can divide both sides by 2, and I'm left with x being equal to 4. Okay? One particular example of this that people are very familiar with but often don't realize they're using is what we call cross multiplication. So when we cross multiply, what we have is two expressions that are separated, both of which are fractions, separated by an equal sign. And you know that when you cross multiply, what you do is you multiply the bottom of this side up here and the bottom of this side up here to get an expression that looks like this. On this side, and an expression, I'm sorry, should be like this, and on this side, an expression like this. Now, one of the things about this, of course, is it looks like we've done something different to both sides of the equation. It looks like over here we've multiplied by x minus 3, but over here we've multiplied by 7. Well, those are two different things. Now, I'm going to tell you that if we haven't done the same thing to both sides of the equation, then what we've just done is wrong. So, how can we understand that we've done the same thing to both sides of the equation? Well, here's what we actually did. What we actually did was not multiply just this side by 7, but we multiplied both sides by 7. However, on this side, the 7 on the top and on the bottom divided each other and canceled out. Similarly, we actually multiplied both sides by x minus 3, except on this side, the x minus 3 on the top and on the bottom divided and canceled out. And once we understand this, we can see that actually cross-multiplying is nothing special. It's the same as what we do every time when we're solving an equation. We're simply doing the same thing to both sides. As sort of an end note to this talk, I want to tell you two things. The first is, I can guarantee you that every mistake you ever make on a math problem will be a violation of one of these two rules. Either you've done something to an expression that has changed its value, or you've done something to an equation that's different on one side than it is on the other. The second thing I want to say to you is that sometimes when we're working with variables and numbers, it's difficult conceptually to understand why something you do might change its value. What I recommend is try in all circumstances to find something in the real world that you understand very well, like for example money, and try and talk about what you're doing in the problem in the same terms with money. As an example, yesterday I was working with a student, and they were trying to assert to me that this is the same as this, that x plus 2 is 2x. Well, as soon as I took out a $10 bill and said, here, I'll put a $10 and 2 loonies down, and you put two $10 bills down, and let's exchange them, because they're obviously equal, he understood very clearly that that doesn't work. So putting things in terms of something real, like money, can often help you to understand why something mathematical works or does not work. Once again, my name is Michael Mustard. My email is m_mustard@hotmail.com, m_mustard@hotmail.com. And feel free to email me if you have any questions on this or any other topic that I can help you with. Thank you for listening.